Lesson 3.4 is more properties of logarithms. These are properties of logarithmic functions. These are properties that we can use when we're solving equations. So if you happen to flip over to 3.5, we're going to be solving equations tomorrow. Okay? There's two different pages on 3.5, but what I'll do is I'll pick and choose a couple examples from both pages and do just one day on 3.5. So 3.4, these properties kind of play into it. So 4 properties up here. The first 3 are what you'll see as we go through equations a lot. Product rule. Okay, the product rule says if you have the log of 2 things multiplied together inside that log, then this can be rewritten as 2 logs that are being added. Okay, so if you have multiplication inside a log, it can be split up into the addition of 2 logs. Quotient rule works the same. If you have division within a log, it can be split up into the subtraction between 2 logs. Now, keep in mind, it goes from multiplication to addition, division to subtraction. It does not go the other way. Okay, so be careful to learn that and not get them confused. The power rule. So what the power rule says here is if you have log base b of r to the c, we can rewrite that by taking that power, that exponent of c, and writing it out front. And again, that comes in handy quite a bit when you're solving equations. And then the last one, we don't necessarily use this one as much with solving equations, but change of base rule. And the change of base rule, log base b of r. If you have log base 7, can you enter log base 7 on your basic calculators? No, okay. The calculator buttons work log base 10 or natural log, which is log base e. Now, with that in mind, what the change of base rule allows us to do is take those traditional log buttons on the calculator and calculate it. So log base b of r can either be rewritten and calculated as natural log of r divided by natural log of b, or log of r divided by log of b using base 10. Technically, you could rewrite them with any base, but the advantage of rewriting with base 10 or base e allows us to use the calculator. So those are the 4 properties we are going to be working with today. The first types of examples are kind of getting us ready for equations, what we might need to use with equations. Expand the following. So log of 8xy to the 4th. Expand that means instead of having one log with everything in one log, I want us to expand this into multiple logs. So working to use those properties up there. Thoughts on how I could do this? What property can I use to expand this first and foremost? Product rule? Because how many things are being multiplied together here? There's 3, yes? There's an 8, there's an x, and y to the 4th. So let's start by breaking it apart into 3 logs. And then we're going to take another step. So I'm going to write this of log of 8 plus log of x plus log of y to the 4th. What other property can I use here? Power property. So the product property allowed me to take what was being multiplied and rewrite it into different logs being added. The power property, the obvious place is where? Y to the 4th. We can rewrite that by putting the 4 out front and making it 4 log y. Now, there's technically one other piece of this that we can also use the power property on. It's not as obvious because it doesn't currently have a power. But which of these pieces could be rewritten with a power that we could then use the power property on? Okay, how can 8 be rewritten here? 2 to the third, yes? So think about this. If I rewrite log of 8 of log of 2 to the third, can we use the power property on the 3 now? Yeah. We can bring that 3 out front. And so there's actually 2 pieces we can use that power property on. So when you have just a whole number, you want to kind of be aware, is that something that is a power of something? 8 is a power of 2 because it's 2 to the third. So I'm going to write this as 3 times the log of 2 plus log of x plus 4 times the log of y. And in terms of expanding, we've used all we can there. We've used our power property and our product property, or excuse me, product rule, power rule. Questions on how I did that? And notice they originally just written log, so I just kept them as log. Okay. Number 2, another one to try expanding. Natural log of the square root of x squared plus 5 all over x. Quotient property first, quotient rule. There's division, right? Division within a log can be rewritten as the subtraction of 2 logs. So I'm going to start off by writing this of the natural log, the square root of x squared plus 5 minus the natural log of x. Is there any use for the power rule in this one? Yeah, square roots. Can they be rewritten as powers instead? Yeah. Something, the square root of something is the same as something raised to the power of 1/2. Because the 1 is the power, but that denominator of 2 is the root, the index. So this could be rewritten as the natural log of x squared plus 5 raised to 1/2. Notice I have x squared plus 5 in parentheses because that 1/2 goes on all of it. It's not 2 separate pieces there. So if I use the power rule, and I take that 1/2 out front, what do we have? (1/2) natural log of x squared plus 5, and then don't forget, minus natural log of x. And realize you're done. That x squared plus 5 is in parentheses, so it has to stick together as one log. And besides the fact, there's nothing that can split up addition within a log. Addition within a log stays as is. If it's multiplication within a log, we can split that up, but not addition. Okay, example 3 takes us the opposite way. So we're reversing our steps, essentially. We have 5 natural log of x minus 2 natural log of xy plus 3 natural log of y. Thoughts on where to begin here? What? I don't want to combine quite yet. Here's the hint I'll give you. We can't use the product or quotient rule as long as there are coefficients out front of our logs. The product and quotient rule have to happen when there are no coefficients out front. So how do I get rid of those coefficients out front? The power rule. Okay, we're going to reverse the power rule here. We were using a power rule to take a power and move it out front. Now we're going to reverse it, and we're going to take the numbers out front and make them powers. So the 5 is going to go on the x. The 2 is going to go on the xy, and the 3 is going to go on the y. So 5 natural log of x becomes natural log of x to the 5th minus 2 natural log of xy, natural log of quantity xy raised to the 2nd, plus 3 natural log of y becomes natural log of y to the 3rd. Now, there's a couple different directions we could go here. What are the pieces you see? What are the types of things we're going to be doing in the next couple of steps? What rules do you guys want to use? What's the subtraction make you think? Quotient? Yeah, because look up here, guys. If it's 2 logs being subtracted, you can go and write it as 1 log where it's being divided, yes? Now, we also have an addition sign over here, which means in that case we can use the product rule. We can do this in a couple of different ways. We can go ahead and do the division and then do the multiplication. How do you guys feel if I reorganize this? Because my brain tends to see, and maybe it's just me, my brain tends to see this better if I have my addition out front and then the subtraction out back. Let me show you what I'm thinking. If I put this natural log of y cubed, it's a plus, right? If I add it after the natural log of x to the 5th, or even put it out front, but the key is to move this minus log to the end. I like what I see a little bit better there. In that, so I'm still going to have natural log of x to the 5th. I'm going to move my plus, so plus natural log of y to the 3rd. And I'm going to put my minus at the end. So it's minus the natural log of xy quantity squared. And again, you can go multiple different ways with this, and we can all arrive at the same step, just going their different directions. What do you see happening with the first 2 logs now? The way I have it written, the first 2 logs are being added, so we can rewrite that as 1 log where the insides are multiplied. So I'm going to write this as natural log, and I'm going to put parentheses, of x to the 5th, y to the 3rd. I'm putting it in parentheses because that puts them together and with that ln. As opposed to, okay, is that y to the 3rd with the natural log, or is it being multiplied afterwards? And I still have the minus natural log of xy squared. So what am I going to do with that? It's subtraction, so I'm going to take that and I'm going to divide it. Now, important note here, guys. When we're combining 2 logs, we're writing it as 1 log. So don't write log divided by log. You only write the log once. So I'm going to write natural log, ln, and then I divide the insides. So I have x to the 5th, y to the 3rd, divided by, now I've been writing as xy quantity squared. What is that xy quantity squared? X squared, y squared? And I'm going to go ahead and do that because we're going to have one more finishing step here. So now I'm at natural log of x to the 5th, y to the 3rd divided by x squared, y squared. And you could have made that x squared, y squared at any point. Some of you may have been wanting to do it previously. Do you see my final step here? Can we clean up that fraction? What do you know about x to the 5th over x to the 2nd? X to the 3rd? What do you know about y to the 3rd over y to the 2nd? Why? Because when the bases are the same in a fraction, You keep the base, subtract the exponents. So this becomes natural log of x to the third y. Okay, that's a condensed example. When it says condensed, you want to get it to 1 log. Okay, period, end of statement. 1 log, assuming all the bases are the same in the problem, as simplified as possible within that log. I'm not going to hesitate to say that you could have gone a totally different order of operations here and still made it there. Okay? Questions on this one? Okay. Example 2 is evaluate the following using the change of base rule. So look back up to rule number 4. How does change of base rule apply to log base 3 of 16? Log 16 over log 3 is what I heard up front. And the way she said it, I wrote it as in our common log, log base 10. Is that the only way you could write that? What's the other way I could say? Could I say natural log? Yeah, you could say natural log of 16 divided by natural log of 3. Can you give me a more specific answer than just this fraction? Yeah, grab your calculators. Try one of them. Whether it be log 16 divided by log 3 or natural log 16 divided by natural log 3. Watch your parentheses. Make sure you end your parentheses in that top part of the fraction. And if you're curious, try it both ways. Because if it's possible both ways, we're hoping we get the same answer, right? Are you getting something? What'd you guys hit? $2.523719.014. That was me using log base 10. What if I use natural log? Do you get the same thing? Yeah. So my point to prove there is, does it matter whether you use log base 10 or natural log? It does not matter. Okay. There are certain situations as you get into logs where there are times where there is an advantage of using a base 10 or a base E depending on the problem. In a general situation like this, it doesn't matter. If I go 3 decimal places, 2.524. Okay. What about example 2 then? Log base 6 of 10. What are you guys putting in the calculator? Okay. You could do log 10 divided by log 6. Or you could do natural log of 10 divided by natural log of 6. Random, let's see if anyone remembers. Anyone remember what the log of 10 is? Think about our rules. Log of 10 would be 1. Because what's the rule? If the base and the insides match, it equals 1. So that's essentially saying 1 divided by log of 6. What'd you guys get on this one? 1.285? I don't think I need to do that on the screen, do I? What about number 3? It's log base 1/2 of 2. So you're either doing log of 2 divided by log of, could you say 0.5? Okay, if 0.5 is easier to plug into your calculator, use 0.5, or can you use 1/2? What did you guys get? -1? You should. Okay, questions on the change of base formula. It's a really easy formula to use. You just have to remember how to use it and what it means. Okay? That's one that I recall in past years asking a question about on the test and people blank on it. So try not to blank on it. Okay, one more piece today. Example 3. Ask us how to describe how to transform, and notice what it says there. How to transform f of x equals ln x. So that has to be the basis of what we talk about, into the following, and graph the following using the change of base rule. So they're giving us a hint that we're going to be talking about the change of base rule here. But, so we have to talk in terms of a transformation. We have to use ln x. We're going to talk change of base rule. Those are some of the hints. So as you look at number 1, g of x equals log base 5 of x. Okay, technically I cannot take my calculator and hit log base 5 of x to graph it, can I? Okay, so how can my change of base formula work here? Okay, officially we could either say log of x over log of 5 or ln x over ln 5. Which one is more appropriate to use based on the directions? Natural log. So I'm going to rewrite log base 5 of x as natural log of x divided by natural log of 5. Now, okay, officially it's something you can punch in the calculator now, but that's not how I want to think about it quite yet. ln 5, natural log of 5. What does ln 5 represent in that denominator? Is it a variable? No, natural log of 5 is equivalent to some number, yes? So this could be saying like natural log of x divided by 5. It just happens to be a natural log of 5 down there. That denominator, I want to pull out front as a coefficient. And so I'm going to rewrite this, see if this makes sense. If I take my natural log of 5 out front, keep in mind it's in the denominator. So I'm going to say 1 over the natural log of 5 times the natural log of x. Think about how I rewrote that. All I'm trying to say is that the natural log of x divided by the natural log of 5 is the same as saying 1 over the natural log of 5 times the natural log of x. Are you okay with that? I mean, here's the idea. It's no different than saying, what's another way to write x over 5? There's an invisible 1 there, right? And so that's the same as saying 1/5 x. I did the same thing here, except there's natural logs involved. Okay? That's what I'm trying to get you guys to see. Because it wants to know what kind of transformation of the natural log of x this graph is. What kind of transformation is that? What's being done to the natural log of x? It's what? Okay, it's being divided by the natural log of 5. Now, the reason I pulled this out front, though, is because I don't want you to think divided. It's being multiplied, right? It's being multiplied by this number, 1 over the natural log of 5. What does multiplying a graph by something do? Shrinks it or stretches it officially, yes? How do we decide if it shrinks it or stretches it? Yeah, you have to look at, is it less than or greater than 1? Do you guys know what 1 divided by the natural log of 5 is? Less than 1? Have you guys checked? Okay. Natural log of 5 is a number bigger than 1, so 1 divided by that. Did you guys, what is 1 divided by natural log of 5? 3 decimal places. .621. And so now you could write it in one of two ways. And I'm going to circle both of these because the directions said, I guess it doesn't say to rewrite the directions, but I feel like we have to. We use our change of base formula. You can either say it's 1 over natural log of 5 times natural log of x, or 0.621 times natural log of x. By writing it as 0.621 times natural log of x, that tells me that this is a vertical shrink by that factor. So I'm going to describe, which means I'm going to put it in words. I'm going to write vertical shrink by factor of, and you could either say, I will accept 0.621 or 1 over natural log of 5. If I had to guess, the book will use the 1 over natural log of 5. I don't think they'll go the decimal route, but here's my thing. I think it's advantageous to at least check the decimal because that tells you specifically shrink or stretch. Okay, do you guys remember what the natural log graph looks like? It has to cross through at 1. We did this last week. Runs up along the axis, cuts through 1, and does something like that, right? That's total just freehand again. What's a vertical shrink going to do to this? What's going to be the biggest difference you'll be able to see? If we're shrinking our vertical values. What's going to happen after we cross through 1? Instead of going up here, it's going to be closer to the x-axis. Okay, so the best I'm going to do is I'm just going to kind of freehand this. I can show you on the calculator, but I probably should have drawn that a little bit lower. But the idea is it's a shrink, and so it's down below. So if I graph natural log of x, and then if I graph 1 over natural log of 5 times natural log of x. Okay, so I have natural log of x, my first graph, my shrunk graph, the next one, zoom 6. So there's my natural log of x, that's the first one. The next one is the one with the vertical shrink. It's not too far down there, right? But it is a little bit. Now, I will tell you something, guys. I always know when someone doesn't really know what the natural log graph looks like because what's the calculator make it look like it does? Makes it look like it stops. Does it stop? No, it runs along the y-axis like an asymptote. So that's something good to know because if you stop it right here, I'm going to know you don't really know what it looks like and you're going totally off the calculator. Am I saying you can't use the calculator? No, but you have to know something to work alongside the calculator. Okay, got it? Okay, let's do number 2 real quick. H of x equals log, what is that, 1/4? Base 1/4 of x. Follow the technique we used last problem. First of all, how can I rewrite this? Change of base rule says this is natural log of x over natural log of 1/4, or 0.25 if you want. How can I rewrite this so it looks more like a transformation? Yeah. Natural log of 1/4 is in the denominator. Pull it out front in the denominator. So it's 1 over natural log of 1/4 times natural log of x. That is one way to rewrite it. I would strongly suggest you check and see what 1 over the natural log of 1/4 is. And let me know what you get. Is that important to know? Negative 0.721 times natural log of x. What's that mean about this graph? It's a shrink again and a reflection. Okay, this is going to be a reflection across the x-axis. Okay, so I'm going to write that out here. Reflect across x-axis and vertical shrink by, you can, probably easiest to say here is the 0.721. Because if you say 1 over the natural log of 1/4, that puts the negative in there. Can you visualize this graph, what this graph looks like before you type it on the calculator? Okay. Not saying it has to be perfect in your brain, but try and visualize it so you know what to expect. Instead of running from the bottom along the y-axis, it's going to start from the top. Am I still going to cut through 1, 0? Yeah, you're still going to cut through 1, 0. And then since it's a shrink, I'm going to hug closer to the x-axis. You can't get these graphs very precise. You really can't. Short of going a whole bunch of decimals and all that. Okay? Okay. Your homework is on page 289, 1 through 28, 39 to 42. Okay? Show appropriate steps and work, as always.